welcome back. Hi. So the last few days we've been talking about special quadrilaterals, those parallelograms that have special things and make them more than just parallelograms. In fact, we threw a rectangle party on Wednesday when our first day back, and we learned how to check ID. We all became polygon bouncers, and we noticed what a shape, when a shape was a rectangle, and we didn't allow it into the party if it wasn't. Then yesterday we were bouncers again, but this time we were looking for rhombi and squares, and we realized that rhombi just have to have 4 congruent sides along with being a parallelogram. And we were checking IDs at the door, and we didn't allow the shape in unless it had 4 congruent sides. And then we got to the square. We realized that the square could get into both the rectangle party and the rhombus party because the square was both. Today, we're going to be looking at trapezoids and kites. We're going to start with the trapezoids, and likely we'll get to the kites next time. So a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. So if we throw a party and we invite the trapezoids, our bouncer at the door is going to check the slope of the sides. And it's going to look for 1 pair of sides where the slopes are equal, and then the other pair of sides where the slopes are not equal. Those parallel sides we're going to call the bases. So those are the ones that are parallel. And then the ones that are not parallel, we're going to call the legs. Los piernas. Okay. Now, the base angles are going to be formed by one of the bases and the legs. So, like, those 2 angles are the base angles. They don't necessarily have to be congruent. If they are, it's something special. We're not there yet, okay? So right now we're going to allow those angles to be anything we want. But these are the base angles, okay? We can create a special segment inside of our trapezoid. It's called the mid-segment, sometimes called the median, but I'm going to stick with mid-segment. The mid-segment is the segment that connects the midpoints of the legs. So I'm going to go to this leg, and I'm going to pick the point right in the middle, okay? And I'm going to mark it. It's in the middle. And then I'm going to go to the other leg, and I'm going to pick a point that's right in the middle of that leg, okay? So those are both midpoints. I'm going to draw a line connecting those midpoints. Like if I had my legs and I tied a string from one knee to the other knee, okay? That would be really weird. But that would be the mid-segment of my legs, okay? If I tied the string from knee to knee, okay? There's my mid-segment. We'll talk about the special property that the mid-segment has in a moment, because I want to chat a little bit about the isosceles trapezoid. Will you toss me one of the pink highlighters, please? And just throw it at my face. Ah, I got it. Thank you. Okay. So, an isosceles trapezoid is a trapezoid where the legs are congruent. Okay, he doesn't walk all like this, right? He walks normally because his legs are the same size. Isosceles trapezoid. We've got some theorems for isosceles trapezoid that talk about these base angles. The first theorem says that each pair of base angles is congruent. Okay? So in our trapezoid, if we know that it is an isosceles trapezoid, I'm having all sorts of issues with my pens up here. I'm so sorry. There you go. If I know this thing is an isosceles trapezoid, I know that the base angles are going to be congruent. So those 2 are definitely congruent, and these 2 are definitely congruent. Okay? Now, if we're checking IDs at the door, our bouncer not only is going to be instructed to look for congruent base angles, But he wants to take a shortcut because there's a line down the block, right? So he's got to go through these IDs really fast. And so instead of checking both pairs of base angles, he's only going to check one. If one pair of base angles are congruent, he's going to say, ah, you're an isosceles trapezoid? Come on into the party. Okay? Maybe he doesn't want to check angles. Okay? Maybe your bouncer doesn't want to check the angles. Instead, he's going to check the diagonals, the ones that go from corner to corner. And if he can get his tape measure and measure the diagonals, and he gets the same measurements, ah, you're an isosceles trapezoid. Come into our very important polygon box. You are a VIP of trapezoids. Okay? All right. We'll come back to catch this theorem in a second. I'd like to do number 1 with you first. Okay? All right, number 1, we want to find each measure. And I've been asked to find the measure of angle D. Here's angle D right here. That's what I want the measure of. And the only information I've been given is the following. I know that these two sides are parallel. I know that these two sides are congruent, but not parallel. And the measure of this angle is 125. That's all I've been told. What kind of shape is this?
Isosceles.
Isosceles what?
Trapezoid.
It's an isosceles trapezoid. Now I need to have that light on you so that you can see it's bright. It's isosceles trapezoid. Isosceles trapezoid have the property where the base angles are congruent. So those two angles are congruent to each other. Right? So if this angle is 125, then this angle is beautiful. Now there's a couple different ways that I can get to the measure of angle D from here. What do you think? How do you think we could get to the measure of angle D? Just call it whatever you think. Don't worry about it whether it's right or wrong, because there's so many ways to do it, you might be right. What do you think? How might you want to try to do this? Using the mid-segment? Okay, if I knew where the midpoints were, I would know where the mid-segment is. I don't have a mid-segment listed, so I can't really use it right now. But I'm glad that you're thinking through that. Remember, we're ignoring this right now, okay? Because we haven't filled it out. Okay? So while not wrong, we can use mid-segment for stuff. It's just not applicable here because I don't have a mid-segment showing. How do you think you could get to that angle D? Okay, add what up?
The 125 and then 125 and subtract it by
And subtract something from it. Yeah, or subtract that from something. You were not wrong. You are on the right track on one of the many paths to do this. Let's follow his line of thinking. This is a quadrilateral, yes? 4 sides? What do you get when you add the measures of all of the angles in a 4-sided shape? If we look back at our notes from right before Christmas, and I know that was a long time ago. Okay, that was like a month ago. We had this thing called the polygon angle sum, where it showed us how to add up all of the angles. Okay? To figure out what the angle sum is of all of these angles, I am going to take the number of sides, which is n. I'm going to subtract 2 from it, and I'm going to multiply that to 180. Okay? This will tell me how much I should get when I add up all of the angles in that figure. If you do the calculations on that, you're going to hit 360. Okay? You willing to go with me on that? Yeah? Okay. Does it sort of seem familiar a little bit, this thing? Yes? Okay, good. Good. You remembered something? Good. So 360. So we're going to follow his line of thinking. We're going to add up all the measures in this trapezoid, and we're going to set it equal to 360. And there's a problem right now that you're already seeing. You're going, I can't add them because I don't know what those pink angles are. But if I don't know what the value of something is, what can I use to represent that value? I can use a variable, a symbol. They're the same measure because this is an isosceles trapezoid, so I get to use the same symbol for both. What's your favorite symbol? It can be a letter or a shape. C? The letter C. Okay. So we're going to name it C. That's going to be our variable. So we're going to go ahead and add up 125 plus 125 plus C equals 360. I was about to write 180, did you see? Which is exactly where you wanted to go with this. Good job. You see it? All right, so we're going to add these two together, combine like terms, and now it's easy for you to see what you're going to subtract it from, yes? Yes. So I'm going to subtract that 250 from both sides and end up with 110. Yes? Please tell me I did that subtraction right. 360 minus 250? 110? Okay, good. I did it right. Divide both sides by 2 and I get 55?
I think it's 52.
No, it's 55.
Grab a calculator, double check it.
Divide both sides by 2?
Yeah, we're dividing both sides by 2 to get rid of that 2 in front of the C.
55.
Yeah, so we're doing 110 divided by 55. I have a calculator for you right here. There you go, love. Okay, so he's saying that for sure it's 55. Go ahead and run the calculator on it and confirm it for us. Let me know as soon as you get that answer. Just shout out, yes, or we're right, or something, okay? Questions? Felt okay? All right. Number 2 is exactly the same way, and I'll leave that for you as your own practice. You're right? Okay, good. All right. So I'll leave number 2 for you for your own practice, okay? All right. Come back up to the top. Trapezoid mid-segment theorem. So now we're going back to what you were talking about, the mid-segment. And we're going to fill in this theorem together. It says the mid-segment of a trapezoid, is parallel to each base. The mid-segment of a trapezoid is parallel to each base. And its measure is half of the sum of the lengths of the bases. Okay, let me talk about what that means for a second. And I'm going to use colors to help you see it. All right, so I have the mid-segments in this figure right there, mid-segment. That is 1/2 of whatever we get when I take one of the bases and add it to the other base. Okay? The measure of the mid-segment is whatever I get when I take the two bases, add them together, divide by 2. It's like the average of the bases. Okay? Let's jump down and let's do number 4 together. Okay? I'll want to leave number 3 for you to practice on your own. Okay? I'm going to redraw that trapezoid. So number 4, if you'll please do me the flavor of redrawing that trapezoid so that we can scribble all over it. There's my trapezoid. Which segment is the mid segment? Which segment is the mid-segment?
And
MN. You're absolutely right. There's our mid-segment. I'm going to color it in yellow. So then this is a base, and this is a base. My mid-segment theorem has a formula, and the formula says that the measure of the mid-segments is equal to whatever I get when I take the measurements of the bases and add them, and then divide it by 2. Here's the measure of the mid-segments. Here's one of the bases. Here's the other base. I'm going to substitute from what I have on my figure into this formula. Okay? Don't think about it too hard. Mid-segment, we were told right here, is 28. So I'm going to do that substitution. I have information on the base. I was told this base is 18. But I don't know what this base is. So I need a symbol to hold the spot of that information. What's your favorite symbol? J. Okay. And so I don't confuse it with this J. Can I make it lowercase?
Yeah.
Okay. So we've picked lowercase j for our variable. It's like x, okay? Okay. All right, I'm going to solve this thing for j. But already there's a problem, isn't there? This thing has a fraction. Oh, how do I get rid of fractions? Okay, we could do 0.50. The problem is while you're not wrong that 1/2 is 0.5, that doesn't get rid of the fraction. It just makes it look different. I want to get rid of it. I don't want it there. So you're talking distribution. Distribute that 1/2 into the 18, but I also have to distribute it to the j. And so the half is still there because I would have 1/2 times j. Bless you. And I want to get rid of it, not just move it.
Don't you like, are you supposed to like multiply it or like against 28 or something?
Okay, he was saying I need to multiply something that will do to the fraction and also to the 28. And I love where he's going with this. Fractions mean to divide, don't they? Hi, side conversation later. Fractions mean to divide, don't they? Yeah? Yeah, okay. So if I want to get rid of divide, what do? I multiply. So I'm going to multiply by something to get rid of this fraction. What should I multiply by?
18.5.
By the denominator.
Oh, 2.
By 2. And what I do to one side, I have to do to the other. You see it? It's exactly what you were saying. We just made it look fancy. Whenever I have this fraction being multiplied by its denominator, the fraction and the thing I multiplied by cancel each other out. Do you want to see why? Do you want to see why? Yes? Do you want to see why? Ethan? Do you want to see why? Okay. Do me a favor and put the phone up so that I can show you the reason why this fraction multiplied by its denominator cancels out. Before I show you why, I want to finish this example real quick. 2 times 28 is 56. And you guys are okay with knowing that we'd be subtracting both sides by 18, yes? And so j is going to be whatever I get when I do that subtraction. I think it's 30, 32? 30. Someone help me with 56 minus 18. Oh dear God, I'm terrible with the numbers. I was guessing 32.
It's 38.
It's 38. I'm so glad I have you here to check. All right. Hi. Guys, in the back. Later. Thank you. All right. Let's figure out why this happens, okay? So you can write it anywhere else that you've got some free space if you want. I'm going to write it on a separate sheet of lined paper just so that I can write big and make a mess. All right, so I had this thing, right? That's what I had. That's what I had. That's what I had. What I'm going to do is every place where things are multiplying, I'm going to exchange that for just putting them in parentheses, okay? So I'm going to put the 1/2 parentheses, this stays in its parentheses, and then that 2 is in parentheses. Are we okay with that? That's okay? That doesn't look like too much magic? That's all right? Okay. Multiplication is commutative. That means order doesn't matter. 2 times 3 is the same as 3 times 2. Okay? So I'm going to rearrange this so the 1/2 and the 2 are next to each other. And now I'm going to multiply the 1/2 and the 2 together. But I don't know how to multiply a fraction and a whole number. I only know how to multiply a fraction with a fraction. So I'm going to trade the 2 for its fraction form of 2 over 1. And my rule to multiply fractions is just to multiply straight across. And so this becomes 2 over 2. And 2 over 2 is the same thing as 1. Well, 1 times anything is just itself. You see it? When you're multiplying fractions by its denominator, you don't have to write all this. Okay? You can just go directly to that and scratch it out. Okay? But this is the reason behind why you can just scratch it out. Fair? Okay. All right. Number 3 doesn't have a solving thing, so it's a little more simple for you. I've done the hardest one for you. Okay? So I'll let you do number 3 on your own for, we'll say for Monday. Okay? Let's go ahead and come down here and let's throw a party. Okay? We're going to throw a trapezoid party. We're going to have a bouncer at the door, and he is checking the shapes for trapezoid. And if it's a trapezoid, then he's going to let them in. And if it's not a trapezoid, he's going to say, I'm sorry, you have to go away. All right? Okay. So here's our shape. Here's the vertices of it. So let's go ahead and draw the vertices and draw the shape and see what things that we're looking at. Okay, so I'm going to, I don't have an origin. I don't have axes. Do I? Yeah, I don't. YOLO, put them anywhere you want. All right, that looks like a good spot for me to put them. I'm going to put them there. All right, so there's A, and there's B, and there's C, and there's D. And so that is sort of what my shape looks like. All right, it's a quadrilateral. It's got 4 sides, and I'm happy. But our bouncer, Ethan, stay with us. Hi, ladies. There's a lot of side chatter. Save it for later, please. Just close it up. Thank you. Okay, ready with me, girls? Okay, thank you. All right, so our bouncer needs to check first to see if this thing's a trapezoid. So he's going to ask for the ID, and he's going to look at the ID, and he's going to check to see if I have 1 pair of parallel lines. Okay, thank you, sir. We're going to check for 1 pair of parallel lines. So I need my slope formula. Here's my slope formula. I'm going to check the slope of this side, and I'm going to compare it to the slope of that side. And then we're going to check the slope of this side and compare it to the slope of that side. And I'm hoping that I only have one pair of numbers that are the same. And the other pair of numbers is not the same. If I have that set up, this is a trapezoid, he gets into the party. All right. So, y coordinate of A minus y coordinate of D, x coordinate of A minus x coordinate of D. I'm going to get rid of my double negatives. And I have 2 over 1. I have a slope of 2. All right, going to do it again with B and C. Y coordinate of B, y coordinate of C, y coordinate of B, y coordinate of C. Get rid of my double negative. All right. Okay, those are the same slopes. Our bouncer is going to well, I have to check the other pair of sides, don't I? Because if the other pair of sides are parallel, I know the picture on the ID looks like they're not parallel, right? But this could be a fake ID, right? The picture could be wrong. So we have to check it. All right, so we're going to check the slope of AB. Y coordinate of A, y coordinate of B. Y coordinate of A, x coordinate of A, x coordinate of B. So there we go. I'm going to do the same thing for CD. Y coordinate for C, y coordinate for D. X coordinate for C, x coordinate for D. Get rid of my double negatives. And I'm going to compare these two. They're not the same. Okay, good. So he's not carrying a fake ID. His picture looks pretty good. He is indeed a trapezoid. So the bouncer is going to let him into the party. And he's going to go on to have a very fun time. He's in the party. He's hanging out. He's having a good time. They're serving water. And he realizes that over there, in the very important Polygon Lounge, they're serving Dr. Pepper. And he'd like some soda. Because water is boring, right? So he wants to get into the VIP lounge, the very important Polygon Lounge. And so he walks up, but we have another bouncer there. Because we don't want just any trapezoid in there. We only want isosceles trapezoids. So we need to check to see if this guy's an isosceles trapezoid. His picture looks like he's not, but maybe that was just a really bad hair day for him. Okay? And his picture looks chweck, but he actually is. So let's go and let's check his ID really carefully. We're going to check the lengths of his legs, and we're going to see if his legs are the same measurement. Even though they don't look it in the picture, they could end up being. So we have to take out our tape measure and we have to measure it. Now our tape measure is your very favorite formula. That was sarcasm, guys. I know this is not your favorite formula. I know you hate this formula so much. Just pretend for me. Let me dream. Okay, I'm going to find the formula the distance of leg AB, and then the distance of leg CD. And once I've found the distance of those legs, then I can state whether he is an isosceles trapezoid or not, and I can decide whether he's allowed in the very important Polygon lounge so that he can drink some Dr. Pepper. All right. X coordinate of A, X coordinate of B. Y coordinate of A, Y coordinate of B. Now I'm just going to do some subtraction inside the parentheses. I'm going to square the things. And then I'm going to add it. Whoops, it went way off the screen. I am so sorry. Didn't realize it did that. There we go. All right. So one of his legs measures that. I don't know what number that is, but I can see a number and I can compare it, right? I can see the 17. Okay. Now we're going to measure his other leg from C to D. X coordinate of C, X coordinate of D. Y coordinate of C, Y coordinate of D. I'm going to get rid of those double negatives. And I'm going to do some addition and subtraction inside the parentheses.
Miss, what did I say next to the 16?
Right here?
Oh, plus 1.
Plus 1, yes, sir. Thank you. I'm writing really small, so sometimes the symbols run into each other. Thank you for asking. All right. Are his legs the same measure? Nope. So is he an isosceles trapezoid? No. And so is the bouncer going to allow him up to drink some Dr. Pepper? Nope. Sorry. You are not a very important polygon. Quadrilateral ABCD is not an isosceles trapezoid. So sad. General questions? That's all I had for this. Thank you so much.